Lesson 5-6 is law of cosines that I'm going to introduce today and obviously finish tomorrow. Law of cosines works a lot like law of sines in that we can use it to solve triangles. So given 3 of our 6 values in a triangle, we can find the other missing ones. Okay, the difference is the types of triangles will be given. So in any triangle ABC with angles A, B, and C and opposite sides A, B, and C, or excuse me, big A, B, and C, little a, B, and C, the following equation is true. Now, notice the typo in the original one, not the ones you guys are copying down and I added, but you notice the typo. Law of cosines. A squared equals B squared plus C squared minus 2BC cosine A. This is law of cosines today. So yes, there is a cosine in law of cosines. Big old typo. So, you will also notice, so as you look at this, it uses all 3 sides of the triangle. So it uses side A, side B, side C. And then this given one, it starts with side A squared, and it uses one angle, and that's angle A. Now, that's one form of it. There are 2 other forms that can be written using B and C. So you could also start with B squared equals, and then using A squared plus C squared minus 2AC times cosine of B, angle B. And you could also have one starting with C squared equals A squared plus B squared minus 2AB cosine of C. You'll notice that whatever it starts with, A squared, B squared, or C squared, that's the angle over in cosine. The other 2 sides, like originally B squared and C squared, are also part of the 2BC. Okay, so there's some connections here, and as we use these more, they'll start to make more sense. I know right now you're looking at it and saying, oh my goodness, that's a long, big equation. But it's still just working with numbers. A couple of key things before we actually look at an example. First of all, general rule about triangle. 2 sides of a triangle, the 2 shorter sides of the triangle, must add to be larger than the 3rd side. So when there are 3 sides of a triangle, there's always one bigger side, right? And 2 smaller sides. Those 2 smaller sides must add to be larger than the 3rd side. Otherwise, it's not physically possible to make a triangle. And that's the no solution type that you'll run into today. You know, like last time there was a time when no triangle was possible. We'll have that happen again. But think about it. If I have this piece, and I'm going to erase this here in a moment. If I have those 3 pieces and I'm trying to make a triangle, can I physically get those 2 shorter pieces to touch?
Yeah.
No, especially when they're trying to come up, it's not physically possible. And so one thing on a triangle, when you're provided all 3 sides, you'll want to check, do the 2 smaller sides add to be bigger than the 3rd side? Okay. When solving triangles with law of cosines, we today are talking about side angle side and side side side. These are 2 setups that we were not able to use yesterday. So when you have 2 sides and the angle in between, or when you have all 3 sides. With law of sines, you had to know an angle and a side pairing to make anything happen. The key with solving law of cosines problems is always to find smallest angles first in order to take into account any obtuse triangles. So, when you have multiple angles to find, whether it be 2 angles or 3 angles, you will always want to find the smallest angle first. And here's the deal. When we put cosine in our calculator, cosine just uses the first quadrant value. Okay? And so with that in mind, it's never going to give us an obtuse angle, but sometimes the angles are obtuse. So by finding the smaller angles first, the obtuse angle we would just subtract from 180 to get it. Okay, so those are the 2, tricks to the trade today maybe. Two smaller sides have to be bigger than the third, and we always find smallest angles first. Now, let's see what we can do with example 1. I didn't get through it all the way in the first hour. I'm not going to get through it all the way today, but we want to look at it. First example is solving a triangle with side angle side. Given side A is 11, side B is 5, and side C is 20 degrees. I have a lot of work in writing on these, so I think I'm going to try and draw a triangle. I'm just going to kind of put it up here. They give me C, so I'm going to put C over here and label it as 20 degrees. They don't give me side C, so I'm just going to call that C. They give me a side B of 5, which I'm going to put up here because it's probably a little shorter. And they give me a side A of 11. And then based on the way I set up my paper, or my triangle, there's angle A, there's angle B. Okay. Based on what we are provided, sides A and B and angle C. We're provided angle C. Which formula must I use, or which version of the formula? We have to use the one that uses cosine C. And the one that uses cosine C is the one that starts with C squared. They gave me one angle. I have to use the equation that uses that angle. So I'm going to write this out over here. C squared equals A squared plus B squared minus 2AB times cosine of C. That's just me copying down the equation so we know what we're filling in, right? You don't have to copy that down, but I feel like I have to as a teacher, at least when I'm in front of you guys. So fill in what you know. Little c squared is just going to stay because we don't know what little c is. A squared, 11 squared, plus b squared, 5 squared, minus 2 times a, which is 11, times b, which is 5, times cosine of c, so cosine of 20 degrees. There are variations of what I can do to find c at this point. Officially, for the most part, yes, you could plug it straight into the calculator right now. Okay, there's just one thing you have to know. I'm actually going to take you through some of the simplifying steps, though, because I think it's also good to be able to recognize what can we and can't we simplify there. So I do want to do that this time at least. Let's see. C squared is going to stay c squared. 11 squared is 121. 5 squared, 25. 2 times 11 times 5. So minus 110 cosine 20 degrees. That was just basic math. There's one more cleanup step I could do right now.
121 plus 25.
Okay, yeah, what can I add and subtract? I can add 121 and 25. Can I subtract 110?
Yes, attached.
Okay, good. And this is why I want to point this out. 110 is attached to the cosine. So what I can do is 121 and 25 is 146 minus 110 cosine of 20 degrees. On the right side, the next thing I can do is plug into the calculator, right? And find what, all that is. However, what are we going to be doing to find c squared in the end? Or, excuse me, what are we going to be doing to find c? Taking the square root of c squared, yes? So if we do that, I'm going to go ahead and write out that c is going to be the square root of 146 minus 110 cosine of 20 degrees. And that's what I want you to plug in to your calculator. bell's probably gonna ring on me, isn't it?
Yes.
Right there is my answer.
Yes, ma'am.
The square root of 146 minus 110 cosine 20? 6.5. Now, if you try it, you still have to write stuff down. Could we have just done the square root of this very first line?
Yeah.
You technically could. Okay? So right there, we have found C. Tomorrow, we will find one of our angles. And the first thing we'll have to talk about is which angle we have to find first. So we'll talk tomorrow.
Oh, yeah.